In this video, we're going to discuss the basics of TCP/IP communications, and in this video, we're finally going to break out of PowerPoint for a little bit, and we're actually going to look in Wireshark as a teaching tool for the basics of IP communications. TCP is the connection-oriented Layer 4 protocol that makes up the bulk of Internet communication. And in this video, we're going to start at the very basics. We're going to talk about the method that TCP uses to initiate the communications and ensure that traffic makes it to its intended destination. So first off, we'll talk about TCP ports. Now, TCP and UDP and several other protocols, but for now, we're concentrating on TCP. TCP uses the port numbers to identify what service on the remote host the traffic is destined for. Ports below 1024 are well-known ports. If you go into Google and search for well-known ports, you'll find that 80 is HTTP, 21 is FTP, so on and so forth. Now this will make a little more sense here in just a couple of minutes when we look in Wireshark and we see with the source port and the destination port. But for now, we're just kind of powering through the facts here. Ports greater than 1024 are available for user services. So if you have a chat server that's not a well-known chat server and you just want to bind it to port 6166, you could bind it to port 6166 on most installations of Linux or Unix or Windows and so on and so forth. Also, any custom-written applications like network management and database servers, for example, may use ports above 1024. They're well known, but they're not actually registered ports, which is the actual term used for the ports below 1024. Traffic originates from a high random port number on the source machine to a specific port on the destination, i.e. port 80 for HTTP, so on and so forth. TCP uses a three-way handshake to establish communications. I've got a little cheesy graphic down here to give you the basic outline of how it works, and then we'll actually look in Wireshark and see how it looks from a packet level. So let's say you've got two machines here, like so, and they want to communicate. So Machine 1 sends to Machine 2, hey, I'm going to start sending you a traffic. I'm going to set the send bit, which is the synchronized bit, and I'm going to send you a sequence number of 250. This machine over on the right receives the packet and says, hey, I acknowledge that I received your packet. I acknowledge sequence number 250. I'm sending back my sequence number of 400, and I'm sending back a SYN and an ACK, or the acknowledgement packet, to your synchronized packet. And then this machine on the left sends back an acknowledgement that says, hey, my next sequence is 251, which is what you were expecting, 250, 251. And I'm acknowledging that you sent me back sequence number 400, and so on and so forth, back and forth it goes. And I picked low numbers for these sequence and acknowledgement numbers. In reality, they're this huge 32-bit number that's pretty much picked at random, although they do increment by known amounts on just about every operating system out there. These acknowledgments is how TCP knows that the packet got to the remote end. I'm sending you a sequence of 250, and then I send you a sequence of 252. Well, what happened to 251? This machine can then say, hey, I missed 251. Can you resend that particular packet? And this machine says, oh, sure, here's 251, and it resends it. Again, this makes a lot more sense when you get down here in Wireshark. Now, this is a packet capture sample off of my lab network here, and I've included it as part of the work files for this particular course. And we're going to look at these three packets right here. Packets 4, 5, and 6 is the three-way handshake, and you see that going on beyond that is an entire conversation between these two hosts. It happens to be a machine that I have doing recording and my proxy server firewall, if you wanted to know what these two addresses were. So the first thing we'll look at are the port numbers. You'll see that the source port, it's recognized it as TIP app server. That's what it's most generally used for, but it's port 3160. Notice it's above 1024, so it's a random high numbered port. Its destination port is HTTP or port 80, so port 3160 on the source is talking to port 80 on the destination. If we delve further into the TCP header and we scroll down to the flags, you'll see this is where the SYN flag is set. And you can expand that and look at all of the flags available to you. Let me resize this window so you can get them all on one screen here. But you can see all the flags that you can set inside TCP. In this case, the SYN is set, saying, hey, I'm wanting to establish a connection to you on port 80. If you look up here, you'll see the sequence number. The relative sequence number is 0 in this case. And so let's look at the response. We look at 192.168.15.254's response to this 104. And we'll collapse this and go back up to the TCP. You notice in this case the source port is HTTP because it's responding back to the initial request. Its destination port is 3160 because that's the port that the request came in on. And you can look up here and see that the SYN ACK flags are set, and we can expand TCP and look at the flags, and you can see that acknowledgement and synchronization is set, and its sequence number is 0, its acknowledgement number is 1. So I saw that you sent me sequence number 0. I'm responding back to say my acknowledgement is 1. My acknowledgement is not 0. My acknowledgement is 1. So if we look at the next packet, which is the ACK to this packet, or the SYN ACK, again, it's coming from port, scroll up a little, it's coming from port 3160 to port 80 because it's coming from my workstation to the web server, to the proxy server. It says, hey, I acknowledge that you sent me number 1. My acknowledgement number back to you is 1. It's an acknowledgement packet. And then if we followed the flow down through, you'd see that this is actually an HTTP exchange between the two endpoints up until you get this FIN packet here, which indicates the end of the conversation between these two endpoints. Again, I can expand this down and we can look at the flags. I'm acknowledging, and the FIN bit is set saying this is the end of this conversation. Tear down the connection between us two. And you'll notice up here the sequence number and the acknowledgement number, they've incremented by obviously random numbers because obviously 300 and some odd packets haven't gone between the two hosts. You look at the timestamps, this all happens within just 0.06 of a second. So again, very, very quick. And you can scroll down through this entire list if you're playing along with your own version of the home game, and you can see all kinds of interesting things. Down here towards the bottom, you'll actually see some encrypted traffic for Dropbox and Telnet, and you'll see SYN resets and so on and so forth, where it was testing out various security mechanisms. For the time being, that concludes our discussion of the basics of TCP/IP communications.